So to set up your machine, you have to just turn the CO sensor to the low, so 0 to 10,000 parts per million measuring. You have to just hook this on the side. Oops, another way. Good. And you will hook up the oxygen sensor too. So if the carbon dioxide is misbehaving, so it should be around 300. So you will press the calibration button. You will wait a little bit, probably. You will press the calibration button. Doesn't want to pick up. Okay, you see it's just doing the flickering, the red. So it's around 400 for you. I don't know what happened. 400. And for the oxygen, you will have, whenever it just touches, it will just do it. It calibrates pretty good its own. If yours is not parts per thousand, you go sensors and not calibrate, change the units. You can change the oxygen gas units, parts per thousand, percent, parts per million, milligram per cubic meter. So you just press parts per thousand for the oxygen, and for the carbon dioxide meters, change the units. You will go parts per million. So that's what you have. In order to measure, you will go sensor and data collection. The default is 300. Oops, 300. Go back, done. So the default duration is on your machine is 300. Please change it for 900. So you click on it and you put 900. So it will be the duration that many seconds, and you will OK. Now it's pretty good. What you will do now is you place the carbon dioxide sensor into the one of the holes, the oxygen sensor into another hole. When you want to just check with the light, you put the light around the container on your table. It will be in the lab. And when you want to just do the no light reaction, you turn off the light. But in order to measure, you press the play button, and this collection overrides the latest. Yeah, that's okay if it's override. Cancel. Oh no. Okay. Discard. Yeah, because I saved that already. And it's going to now measure for 900 seconds. It's a play now, and this is the time that it starts to measure it. Now in my house I have to turn off the light or make it a little bit dim, but it will be totally fine. So that's what you will do now. You have what I did. I put together the spinach in here with the oxygen sensor and with the carbon dioxide sensor. I put a light around the container, spinach inside, and I used the Labquest to figure out the tendency of the carbon dioxide in the container, as well as the tracking the oxygen content in the container. What you will do now, analyze your data. Well, at the first, in order to warm up the carbon dioxide sensor, the red one, I had to wait a little bit, so I will not take into consideration that part. But from here, I hold the cursor. Oh, okay, now start again. hold the cursor and pull it down all the way down. I will press on analyze and you will do curve fit. The curve fit, you will on X the oxygen, well, you will not have any problem with that. You X the carbon dioxide at this point. Now it gives you a little bit of the shot in here. You will again highlight the where it's going to go down, choose the curve fit, go linear, and you will get the actual rate. The M is the rate of the carbon dioxide decreasing. So you write it down in your notebook, minus 0.18969. That means the rate of carbon dioxide usage by the plant because of the photosynthesis. And that means this is how many parts per million carbon dioxide is used up per second. That's really the rate. You go back to the main screen by clicking it OK. You go again, analyze, curve fit, you on X the carbon dioxide, analyze, curve fit again. Oops, I did not X. Oh, well, what is that? Okay, it's the oxygen. I will do the curve fit from the beginning up till it goes to the top, pretty much, and you go curve fit, linear, we assume it's linear motion, up till here, and the coefficient is actually the rate is 0.0035661. That means it's not negative, so it's gaining, so the container gets oxygen, the container will gain oxygen. Now that means 0.003561 parts per thousand gas molecules will get released over a second. So that's what you will do for the first when the light is on. You will repeat the So this is what I have with the Labquest. Hopefully you will pay attention and you will just remember that ignore now the oxygen, because I have no idea why it's like that. Probably the sensor has some defects, but definitely for the carbon dioxide, you in the dark, I just pull it up here and I will analyze the curve fit for the carbon dioxide. Curve fit, you just pick linear curve fit, and this is the actual rate for the carbon dioxide emission parts per million per second. This is the rate how much it just emits the carbon dioxide. Carbon dioxide is not going to be used because, well, it was dark and photosynthesis did not take place at that point. So for the oxygen investigation, I will send back the probe, probably it's too old. Which way should it go? Basically, it should go downwards. So it would look like this, using up oxygen gas as the cellular respiration will take place, using up oxygen to make energy for itself, ATP. That's all basically. So please record the rates for the carbon dioxide as well as the oxygen in the presence of light, as well as in the lack of light. Excellent. Done.